So welcome learners back to Tech Course Mastery. So this one is a special one. In this one, you will be studying the essentials of vectors, starting from the very basic theories to the numericals and then into the details through the help of diagrams. This entire playlist will be divided into 11 videos, one after another. You are expected not to skip one of them, just go by the order in which it is uploaded so that you can learn most effectively. So buckle up and enjoy the first video, which is about the types of motion. Please enjoy. So welcome to today's video. This will be on concepts of vectors. Now to make this video most effective, you need to take some actions. Only actions can bring results. So the four most important actions that you need to take are: action number 1, you need to have some active note taking. You must indulge in some active note taking while this video is going on. Then action number 2, while watching the video, it will be pause and reflect. Whenever at the end of each segment you have to reflect on certain topics, please pause it and then think about it and then proceed for the next video. Don't watch it like a movie as if you have to complete it in one single shot. Action number 3 will be clarifying the concepts. Whenever there are some unclear concepts that is arising, please pause and seek clarification from the resources that are available to you. These resources can be a textbook that you have or the PDF links which will be attached with this video. The fourth and the most vital action that most students forget to take is whenever I'll be solving a numericals, there will be some diagrams associated with that. Please draw those diagrams and solve the numericals along with me. Only then you will have the concepts ingrained in your brain properly, and then only you can make this video most effective. So now let's see what are the things that we are going to learn in this video. So the contents of this video will be: firstly, we are going to learn about the types of motion. Then we are going to learn the physical quantities, that is scalars versus vectors. Then representation of vectors, how to represent a vector in 2D as well as in 3 dimension, position and displacement vectors, resolution of a vector, types of vectors. Then we will have addition of vectors, subtraction of vectors, then multiplication of a vector with a scalar, then dot product of two vectors, and then cross product of two vectors. So that will be all that is required at this level in vectors. So please pay your full attention as if you have paid for this video, and then let's proceed to the segment 1, which is the types of motion. So as you can see on the screen, mainly the types of motion or the motion can be classified based on three things. Okay, whether it is happening in one dimension, that is called one dimensional motion. If the motion is happening in 2 dimension, then we call it a 2-dimensional motion, and if the motion is happening in 3 dimension, then we call it the 3-dimensional motion. Now what is about 1-dimensional, 2-dimensional and 3-dimensional motion? So basically, before getting into that details, we need to first understand what are the things that will be required to basically explain a motion. To explain a motion, the most important thing that you need is a reference point. That is a point with respect to which all the parameters will be measured. These parameters can be displacement, velocity, acceleration, and so on. So in one-dimensional motion, a single coordinate like x-axis will be enough in explaining all the parameters of motion. It can be y-axis, it can be z-axis, but only a single axis will be enough for explaining the entire motion, for calculating the parameters of the motion. Only one dimension or one axis is required. That is called motion in a straight line. In 2-dimensional motion, you will be requiring two axes. Okay, it can be either x or y, it can be y and z, or it can be z and x. So it can be any two axes, not necessarily x and y, but for easy understanding, in 2 dimension we will consider x and y. Okay, so now what is a 3-dimensional motion? In 3-dimensional motion, basically we will be needing 3 coordinate axes to explain the motion. Okay, so a three-dimensional motion must have a coordinate system having three axes, x, y, and z. All of this x, y, and z will be important in explaining the motion. So you cannot calculate a parameter just with the help of x-axis or y-axis or z-axis. So now let's get into the details of each type of them and how they are further classified. So as I have told, in one-dimensional motion, the motion happens in a straight line. So let's see here. So this is what a one-dimensional motion will basically look like. Okay, the first picture on the left. So as you can see, there is a starting point or initial point which is called A, and there is an ending point or final point or the terminating point which is called B. And a particle moves from A to B through this straight line. That is the shortest path. Okay, it is just a straight line through which a particle moves from point A to point B. This straight line could be inclined also. A particle can move from A to B in this direction also. Then also it is a motion in one dimension. It can move vertically also. Then also it is still a one-dimensional motion. Sorry, it's not totally vertical. So it will be a straight line. So like this, if a particle moves in a straight vertical line, that will also be a one-dimensional motion. Only the axis will be different. So to explain a one-dimensional motion which is happening in the vertical direction, we will be requiring y-axis, only the y-axis. To explain a motion which is happening in the horizontal direction, we will be needing only one axis, which is the x-axis. Now what about this? If the motion is in this way, the inclined one, you can basically shift the coordinate system. So you can make the x-axis get aligned along this inclined path. Then this motion can be explained with the help of x-axis. So it's not necessary that the motion is happening in the horizontal or in the vertical direction only. The motion can be inclined also, but it has to happen in a straight line. Then only we can call it a one-dimensional motion. So what are the types basically in one-dimensional motion? As you can see on the screen, the first one is called the rectilinear motion or the linear motion or simply linear translation. This is the motion that I have explained just now. The second type of one-dimensional motion is called oscillation or vibration in a straight line. So what is that? So if we consider, say this is a point A and this is a point O, and then this is a point B. Okay, and now if we have a particle, I'll be showing the particle with the red color. So if a particle is initially at this point, at the point O, okay, here the particle is initially. Now the particle moves from O to say B, okay, it comes to this position, and then from B to O, okay, and then from O to A. So then from O to A, and then again back from A to O. So the particle has made a complete cycle. It has moved from O to B and then back to A and then to O. So initial and the final points are basically same. The particle started from the point A, moved to the point B, then back to O, then to A, and then back to O. So it has completed a one cycle motion, and the initial and the final motions, initial and the final positions are same. And importantly, the particle had moved in a straight line. So O to B was in a straight line, from B to O again in a straight line, O to A again in a straight line, and from A to O back in a straight line. So the entire motion had happened in a straight line, as I'll be showing now, say in this line. Okay, so this is the line along which the entire motion has happened. So this type of motion is called oscillatory motion or vibratory motion, where the particle moves to and fro about a mean position, but it is happening in a straight line. So that is called a vibration in one dimension. Okay, and the mean position here is basically the point O. Okay, B is one extreme point and A is another extreme point. We can call B as the positive extreme because it is on the right side. Conventionally, right side is taken positive, and the point A can be called as the negative extreme point because left side is taken as negative. You can consider it reverse also. It's not a problem. Basically, A and B are the two extreme points and O is the mean position. Okay, So that is all about vibrations in a straight line. Now let us see what is a two-dimensional motion and how it is classified. So two-dimensional motion can happen in four different ways, as you can see on the screen. The first one is a translation in a curved path. Okay, translation in a curved path. What is that? So let us go to this one. Okay, let us go to this graph, as you can see, or this diagram, as you can see. So the particle was initially at the point A, it moved to the point B, but not in a straight line, but in a curved path. As you can see, this is the curved path, that is the red color line. As you can see, the particle had moved throughout this red colored path, and it was a zigzag path to B. So you cannot align a single axis along this path. Okay, it's not possible. If you just draw an axis, it will be like this from A to B, and this object, the path of the object, is sometimes above that straight line, sometimes crossing that straight line, sometimes below, and it's a very bizarre kind of motion that is happening with respect to the straight line. So a straight line, a single axis, is insufficient to explain or to measure the parameters associated with these kind of motion. So in this motion, instead of having a so in this kind of motion, instead of using a single axis, we will be basically using two axis system that will explain the motion completely. So if we have O to X, this is the X axis, and from O to Y, this is the Y axis. Okay, and now this point A can be explained with the help of a coordinate. Say it is x1 comma y1, that is the coordinate of the point A, and it goes to the point B whose coordinate is x2 comma y2, and in this way any intermediate point in the path, that coordinate can be measured very easily, and the parameters of motion associated with that point can be calculated. Okay, so here we need two axes to represent this kind of motion, and the object has moved from one point to the other point, and it didn't came back to the point A. So this is not a vibration, but this is a translation where the object starts from one point and ends in a different point, but this is happening in a curved path. That's why it is a two-dimensional translation. Now let's see what is the second type of motion in two dimension. That is a purely rotational motion. Okay, a purely rotational motion. So what is a purely rotational motion? So if a particle moves in a circular path, so if this is say a circle and the particle moves in this circle, this is not absolutely a circle, sorry for that, but I'm trying to explain. If a particle say is at this point, okay, this is the point A, and it moves in this direction, in the clockwise direction, in the anti-clockwise direction, it moves and comes back to the point A. So this is a rotational motion. This is a purely rotational motion, and this also cannot be explained with the help of one axis. We need two axes, either x and y. So x axis can be in this direction, y axis can be in this direction, and that will help us to spot all the points, the coordinates of the points, and the motion can be completely explained. So this is purely rotational motion happening in two dimension. Then the third kind of motion, that is oscillation or vibration in a plane. Whenever we have a two-dimensional motion, we call it a motion in a plane. Okay, so oscillation or vibration in a plane. So here also vibration is happening, but in a surface, in a plane, not in a straight line. So how that can happen? We already know the example of this. We have seen it many times. That is a simple pendulum. So if this is the roof or the fixed structure from which a string is hanged, okay, and we have a metallic bob below. Okay, this is the mean position, let's say. Now this bob can move right and left, so it this string will have one position, this one on the extreme right side, and will have a position, this one, in the extreme left side. Okay, so the motion here is basically happening, I'm showing in red color now. So the motion is basically happening from here to here. Okay, so let's name this point. Let's say this is the point O, this is the point A. It comes back to O and then to the point B, okay, and then back to O. Okay, so this is a oscillation because the particle starts from the point O, and moves to point A, B, and then back to O. Okay, so initial and the final point at the completion of one cycle is same. So this is a vibration, this is a oscillation, but it cannot be explained with the help of a single axis because the path here is curved. It is not a straight line path. So it is basically arc of a circle. So this is basically arc of a circle. So the path is curved and the shape is the arc of a circle, which can be explained again by using two axes. Okay, we need here two axes like this. So this will be the x-axis here and this will be the y-axis that can explain this kind of motion. So this is a vibration happening in two dimensions. So that will be a vibration or oscillation in two dimensions. Then we have a mixed motion in a plane. Okay, mixed motion in a plane, that is basically a mixture of all these three. It can be translation in a curved path, purely rotational motion, oscillation. All these three, if is mixed together, that will give rise to a mixed motion in two dimension. Let us have some idea about what it can happen basically. So say if a particle starts from this point. Okay, I'm showing a mixed motion in two dimension. Particle starts from this point, say it translates. Okay, it translates up to the point B. Then it has a rotational motion. Maybe it takes two turns. Okay, it takes two turns. Then goes back to the point, goes to the point C through a curved path. Okay, so we had a purely basically a straight motion, then we had a curved motion, then we had a circular motion, and say it returns back to the point A. Okay, so if this is the path, basically this is the path, and the particle goes from A to the point B, goes in a circular path, then through a curved path to C, and then back in a curved path to the point A. So the particle has came back to its initial position. It has to be an oscillation. Then what happens here? It has moved through a straight path, through a curved path, and in a purely rotational motion. So this is basically a mixed motion in two dimension. Why two dimension? Because again, it cannot be explained with a single axis. With x, y, z, we cannot explain it. We need two axes for this. So we will have a y-axis and a x-axis, and then we can identify all the points and explain this motion completely. So this is a mixed motion in two dimensions. So that is all about the motion in two dimension. Now next thing that we need to learn is the three-dimensional motion or motion in space. Okay, three-dimensional motion or motion in space. So the motion in space can be also of four types. First one can be translation in space. So it can be a motion, not a straight motion. Remember, whenever a translation happens in a straight line, that goes into one dimensional. Okay, when translation happens not in a straight line but in a surface, that is two dimension. When translation happens not in a straight line, curved, but in space, in three dimension, that is a translation in space. Let us see an example of that. So this diagram, as you can see here, this one is the example of translation in space in three dimension. So this cube you can imagine like a box or maybe like a room. Okay, we have got four walls, a roof, and a floor. Okay, so this is a simple room. Let us consider there is a mosquito. Okay, a mosquito is there at the point O. Now it flies from this point to the point A. So the mosquito flies from the point O. From the point O it starts, it moves in this curved path as shown in the red color, in a crazy path, and it flies to the point O. So it has moved from one corner to the other in an extremely curved path in space. So this is translation in space or translation in three dimension, where the motion has happened in a crazy manner, but initial and final positions are different, and we cannot explain this with the help of one axis or two axes. Rather, we need three coordinate axes, that is x, y, and z, to explain all the points that were there in the path, and then only we can calculate the various parameters of motion. So this kind of motion is called translation in space in three dimension. Then the second kind of motion in three dimension will be called basically the spiral motion in space. Okay, the spiral motion in space. Now what is spiral motion? Spiral motion is basically a kind of motion which happens in which the movement is basically like a spring. Okay, so there is translation as well as rotation. So let me explain. If we have a particle here, I am explaining the spiral motion. Okay, what is a spiral motion? Okay, so if a particle is at this point, now it moves like this in a circular path, but it is advancing in the right side direction also. So it is again doing a loop, okay, moving in a circular path but advancing in the right side also. So this kind of motion, as you can see, is basically a spiral motion. Okay, this is a spiral motion. So object basically rotates, okay, in a circular path but also translates in another direction. So it is translating in this x direction, and this rotation, that is this circle, which I'll be painting in red now. Yeah, so this one which I am now drawing in red, this is basically a circle. Okay, I'm just showing you the part of the circle which is the part of this spiral motion. So if we take this circle is basically like this, something like this, that circle, and this circle exists in the YZ plane. Okay, so if we have this is the y axis, if we have this as the y axis and we have this direction as the z axis, then this circle sorry so this circle is basically this one that I have here drawn. Okay, this circle can be drawn here. I'm showing it oval because it is seen from the sideways. Okay, it is seen from the sideways, so we can explain it with the help of a y-axis and a z-axis. Okay, it is on this surface. So this is y-axis and this is z-axis, and the object is moving in the x-axis. Okay, so here the object or the particle basically rotates in the yz plane and translates in the x direction. Okay, again I am telling, rotates in the yz plane and translates or moves in a straight line along the x direction. So this kind of motion is called a spiral motion. Okay, this is a very typical motion which happens only in space. You will be coming across this kind of motion when you will be studying electromagnetism in class 12. Basically a charged particle will be moving in this way in a electromagnetic field. Okay, so that will be an example of this kind of motion. So the third kind of motion in 3 dimension will be oscillation or vibration in space. This you can understand, as oscillations were happening in 2 dimension, in 1 dimension, it can happen in 3 dimension too. How it can happen? Very easy. It can be, or let us take this example. Yeah, so it can be, I'm now showing a vibration. If a mosquito starts from the point A, moves in this crazy path and then moves in another crazy path back to the point O, this is basically a vibration in space. Okay, vibration or oscillation in space, where the particle has came back to the initial position, but to explain its motion we will be requiring 3 axes, not 1, not 2, but 3 axes. So this is a vibration in space. Now the fourth one is, as you can understand, which is a mix of all this. Okay, so it can be a mix of all this. If a particle has a translation motion, spiral motion, as well as oscillation or vibration in space, all this mixed together will make a mixed motion in space. Most practical motions that we see around us are basically the mixed motions, because they are neither truly translational, not truly spiral, not truly oscillational or vibrational motion. So these are basically the types of motion that you need to know. Okay, so if you have any doubt, please pause and go back to the part that you had not understood and then come back to the next part. So the next part will be now the frames of reference. Okay, this is also in this to explain a motion, basically we need frames of reference. Now what is frames of reference? As you can see on the screen, a frame of reference is basically a set of coordinate axes, okay, attached to an object or a point. So if we have a system in motion, and then we attach a coordinate system. It can be one axis system, it can be two axis system, or it can be three axis system, depending on whether we are doing in one dimension, two dimension, or in three dimension. Okay, so the reference frame is basically a system of coordinate axes that needs to be attached, okay, to a point or an object in the motion, in a motion system, to explain that motion completely. Okay, the point basically to which the object is attached is called the origin. Okay, it is normally called the origin, the point to which the frame of reference is attached. Now everything related to that motion, such as displacement, velocity, acceleration, force, energy, everything is calculated with respect to the frame of reference. Okay, it is explained with respect to the frame of reference. So frame of reference is the first and foremost things before solving any problem in mechanics or in motion in physics. You need to first define a frame of reference with a origin fixed to an object or a point, okay, where the motion is happening. Then the frame of reference can be at rest, it can be at motion, depending upon the specific situation. So the axis, if say I'm sitting on a train and I'm imagining a coordinate system attached to my train seat. So to a person who is standing outside, the coordinate system will be moving along with the train. Okay, but to me, as I am sitting on the train myself, and with respect to the chair of the train or seat of the train, I'm not moving, so I'll see that a coordinate system is at rest with respect to me. So depending on specific situation where the observer is, the coordinate system may appear to be at rest or it may appear to be at motion. Okay, so it is not necessary that it has to be at rest or motion, because the concept of rest and motion is relative. You can think that I'm sitting at rest in my house, but with respect to say the sun, earth is continuously moving, so I'm not at rest. So it depends relatively with respect to what you are measuring. So the frame of reference with respect to a specific observer can be at motion, and with respect to another specific observer can be at motion. And then the frames of reference can be one dimensional, it can be two dimensional, or it can be three dimensional. So basically you have already understood, to explain a motion in one dimension we need a one dimensional reference frame, that is a single x-axis, single y-axis, or a single z-axis. To explain a motion in two dimension, we will be requiring a two axis coordinate system or two axis frame of reference. We can take x and y, we can take y and z, or we can take z and x. And the three dimensional reference frame will be used to explain basically the three dimensional motion, where we will be having, will be basically having the motion happening in space, that we will be requiring three dimensions to explain that motion. Okay, so that is basically all about the frames of reference, and that completes our segment 1, which was about the types of motion. Now don't forget to see the part 2 of this video, link in the description.